All right, so I'm going to go over as quickly as possible the Rbox that I've been talking about, as well as the biggr package, which I've been working on. So biggr is a wrapper for the Bodo 3 module in Python. It allows you to access and work with AWS pretty seamlessly, especially EC2 and S3 servers, S3 buckets. So we're going to load the package, and what we're going to do is use something called an AMI, which is more or less a pre-configured computer that I've made available to the public, which runs our studio server, Shiny server. It'll host your website. You can run GPU instances. So cool thing about EC2 is that you can boot up and like a really big like supercomputer, and you can shut it down and then pay half a cent an hour to host your website. All of this can be done from one folder within this bucket or this server. So each time we run EC2 instance create, which is just the function that I made, we give it an image ID, a key name, which you create, how much storage, the security group, which we can talk about, and then a startup script, which here is just nothing, and then the type of instance that we want to run. So let's do that now. What's going to happen is it's going to create an IP address that we can access all this stuff from. So we have this IP here, which whenever we go to Google Chrome here in a moment, we're going to be able to actually see a website. So this really is like everything you want from one folder on a computer that's remote. So you can create a remote database, access it anywhere in the world. You can access Shiny server anywhere in the world. You can work with GPUs from your MacBook Air. Really, the sky's the limit. I really think that you can do anything that you need to with R here. I've already pre-configured a load-balanced API as well, which I'll show you. So there's a whole lot of stuff that I want to show you really quickly. So website's up and running, and then our studio server is right here, 8787.3838 is Shiny server. All right. So what we have to do is use the key pair first to access it. Exit. Okay, need a new terminal. CD. Yes. Sudo password Ubuntu. This is how you change the password for that particular user. He does not have one yet. Pass. Now it's updated. So now we can go back to Google Chrome, and I can say Ubuntu pass, and now we're in. So, and you notice that, hey, we did just spin up the server. Actually, while we're here, one thing is that every time you start and stop an instance, the IP address will change unless you allocate it with a elastic IP. So what you do is you say, I need a new elastic IP address. That is the IP address. And with this box that we just spun up, we associate it. And then, yep. Click all the buttons I did. And now we can access it from here. Yep. And this IP address will not change. And then what you can do is you can do something like me, where my website, you go to dronr.com, 8787, our studio server, APIs, whatever. So Ubuntu pass. All right. So now we're at our new box. All right, well, first off, you're going to get a website. So that's good for any good R person. Hey, I'm in the box. You drop your site in the home Ubuntu website folder, and then you have your website, right? So your website is served from here. And now we can look here. Indeed, hey, we were inside the box, right? So drop your site in that folder, it will be served. Using root 53, the root 53 is where you actually set your domain name within AWS using that elastic IP. All right, next, Shiny server. So our studio, Shiny server examples, GitHub. it's more or less just drag and drop once you have the packages installed. So in this case, we're going to go to GitHub. We're going to do git clone. It's a terminal. Let's cd into Shiny server. Git clone that. And now we go to 3838 Shiny examples. And boom, Shiny apps. It's that easy to install. All right, so now let's look at databases. I have Postgres and Mongo installed. They don't start right away. You need to start them up, and I can help you set it up to do it on reboot. So Postgres, and this again, this is a remote server, so this database has access to has access for anyone who has the credentials to get to it. You don't have to be on the box. This is a real remote database. So we've started up Postgres, we've made a connection, and then just to prove it to you, we will come over here and say on my local computer, I want to access this box, and then I want to write to the table and get a connection to mtcar. So this is actually running on that box. So you spin up a big one, good for processing 10 million rows, and you can do it on AWS instead of locally if you want. So it's that easy. Same thing for Mongo. So you've got Mongo database right here. Again, it's all, you can access it remotely. Stop pushing buttons so fast. I do want to add MySQL as an option as well. I'm just interested in using it. I typically use Postgres. With that, our PostgreSQL, you can also access Redshift as well. Okay, well, it's not quite ready. It's just going slow. There we go. So we inserted a Mongo, took from Mongo, closed, and then deleted and stopped. All right, so that's running. That worked. That worked. All right, next is Load-Balanced API. So let's go to the projects folder, and then we'll go to Plumber package, and then go to this inst. Okay, so Plumber, in order to really do something with it, you need to build out your API in a Docker file. So this is for all of the Linux binaries you'll need. You can just tack them on here. Any of the packages that you need, I'll configure Java for you, and then you just put the packages that you need, and then wherever it is on GitHub, pop it right there. And then using Docker Compose, we can spin up like 10 of these Docker containers and run like 10 or 11 instances of R at once in order to have like a really high capacity API. So for example, what we're doing here is I've configured Nginx for you conf. So your home website is right here. But then whenever you pass the API URI, it will send those requests distributed equally over these 10 different endpoints. So again, if cat docker compose.yaml, we see that within the Docker container, the API is ported to 8000, but it's routed to 8009 within the instance. So if we said docker compose up -d for detach, which means that we don't sit here and run it, we can actually get back to the bash terminal. What's going to happen is now we have all of these APIs loaded up. So if we take the value here, okay, so we're going to first let's just do this. Let's say 8003. Wait for 1 second. API ran successfully, and so all of these Docker containers are now being routed to the outside. But if we hit API, we're going to get one of those 10 or 11 containers, and why that is great is for this reason right here. So what we're going to do is let's just copy paste this, and then let me take this parameter here and then change it. And then for n is equal to 1. So we're going to really hit this API hard here, as hard as we can. But we can only get a request a second because we said, hey, we're going to hit the wait function. It makes you wait a second, and we're going to wait. So like you can't get another request done until that one's over. However, because we have 10 of these things running, we can hit them all at once. And so you see that, we're hitting like 9 or 10 of these instances, and then every second we get 10 of those requests back instead of 1. That's really great because you can really scale your APIs. And again, I've already pre-configured all that stuff, so you just got to copy paste with your own package. What else? Okay, so now we're going to stop it, and then we're going to run a GPU. So the instance ID we've pulled, we're going to stop it. Google Chrome is going to say, see, we're stopping it from R, right? And then once this is stopped, we can change the instance type. We're going to change it to a P2 8x large, which has 8 GPUs. That's pretty cool. And we're going to run a deep learning model real quick, and then we're going to stop it, and then we're going to, turn back on a T2 small or something. So once it stops, it just takes a second here. Okay, stopped. So now let's do a P2 8x large, and then start. So now you'll see, boom, P2 8x large. So you don't actually have to use the console here. And this tends to take a second. So I have pre-configured XGBoost, CatBoost, and then TensorFlow and Keras to work with the GPUs on AWS. LightGBM, for some reason, is not compatible with any of the GPUs that run on AWS. It's a bit of work to get those things pre-configured, but that's what I'm good at, so that's why I'm doing it for everyone. So if you have a MacBook Air, you can still do GPU stuff. Just look at the pricing. It could be kind of costly to actually run a GPU specifically. And actually, while we're on it, pricing, you're going to look at on-demand. So T2.nano, that's what I run my site on generally. Come on. It's in here somewhere. There it is. So that's like half a cent an hour, but right now we're putting up a P2.8x, which is like $7 an hour. So I really want to get this thing going. All right. So once the GPUs are running, it's really quick. But they first have to like talk to each other and kind of get data loaded, and that tends to take a moment. So I'm just going to show you that you can in fact run these GPU models. You can also run it on CPU. So here we're going to uncomment. We've got 8 GPUs, so we're going to use them all. We're going to hit source. We're going to let it run. So I've already installed TensorFlow and Keras. So you just you work on your model, you get it going, and you get it to the point where it actually starts to run. And then you say I have a CPU and I'm working with like 400,000 images, and this is going to take 2 weeks. So you scale up, you turn on your GPU, you run the model, you pay your couple bucks, and then you scale it back down, and your data is still all here, right? So you can run your 16 GPU deep learning model and then post it to your website all from the same folder. So it makes it super simple for you to do all this stuff. So it's going to take a second. I'd like to do a little bit of research and see if there's a way that I could speed up this configuration. So it, just give it a second. Whenever this starts running, just believe me whenever I say that trying to run this on a MacBook Pro, this particular model takes a substantially, large amount of time. Substantial, I don't know words. It sucks. So using a GPU is worth the couple bucks. So GPUs are still kind of like waking up and getting going, and we just restarted this instance, so sometimes it just takes a minute to get going. But I want to prove it to you, so here's a XGBoost example, here's a CatBoost example, and then GBM actually runs on GPU, but these particular K80s, K40, K100, for some reason, specifically those, it's not compatible. So here it goes. So 8 GPUs. Here in a second it'll actually do the work. So it spreads all that work over all of them. Still getting going. There it goes. So, we're running this model really quickly. So there, I've proved it using 8 GPUs to run Keras. All right. Other than that, I think that's about it for now. There's a whole lot more to talk about, but for the moment, that's all I have. So if you want to use it before I get documentation up, let me know and I will help you get it set up. Alrighty, thanks for listening. Bye.